Hello and welcome to another video about Unreal Engine 5. In this video we'll continue with the MLRS video. Uh, now first let's make some changes here because I want to limit the uh, I want to make the launcher do not shoot when the rockets or the launcher is facing the uh, it's facing the cab, the vehicle. So if it shoots, it will destroy itself. So first we need the yaw and clamp axis to make it 360 degrees and check the range in range. I think the range that the forward is 0. I want it between, let's see, 25 and minus 25. We do not use the clamp. The clamp will make it 160 degrees, but use it as is without clamping. Let's see, between minus 25 and 25 branch. If the yaw angle is between these values, you will not be able to shoot. If it's outside these values, we will be able to shoot. Now let's check. Now we cannot shoot. Left, we can shoot. Here we cannot shoot. Now we cannot shoot. Let's give it another check. Yeah, to make it more realistic. If it is between the minus 25 and 25 degrees, but we want to check the pitch. If the pitch is above, let's say 15 degrees, we can shoot. Make it look better. Now the pitch, we need the range, or no, above. We do not need the range. Above, let's say 15 degrees. Another branch. Now we put the branch here, this row. If it's above 15 degrees, we can shoot. If it is below, we cannot shoot. Let's check it. Now we cannot shoot. Let's see. Here we can shoot. Shoot. Cannot shoot. We can shoot now, and here we can shoot. Now wait for 5 seconds to reload. Now we can shoot again. Now in this video I will make us able to predict the trajectory of the projectile. We will be able to predict where it lands. This now let me just now just let me move this away and comment on it. Shooting. I think I have a problem with expressing the words, but I hope I will get better soon. Now let's make a new custom event. Call it predict projectile arc or curve or trajectory. Now, what we need first is to make the landing point that we need, that we want the projectile to land in. How we calculate this? We make a line trace that originates from the distance that we need, that we want it, and this distance we will use the location. And let me show you, because if I show you, you will understand it better. Now, the starting point will be the socket, or let me just take it from above here. Where is the socket? This one. The socket location. Break. We need the location and the rotation. The rotation, we need the forward vector and multiply the forward vector by a float. This float we will get it from multiplying the pitch. To be more accurate, let's take the pitch of the let's take the pitch, this one, and multiply it by the value you want. So, the more you increase the value, this value, the more you increase the range of the projectile. I will make it 1000, and this value is the range or the distance that we need. This will give us the end location of the projectile. Now we need a line trace. And trace by channel. Now the start location will be the same. The start and end is the same location, because I do not need I want this line trace to be the start point for my end location of the projectile. Now break the hit result. Now what we need is another line trace. Sorry. Here we need to add the end. We want it to be plus 5000. We will need this value because we want the line trace to originate from the location that we calculated, and also make another line trace that hits the ground, because this will originate from the ground, from the end point. It will not help us, because it will be at the same level of the launcher, and this will give us a lot of errors with the range of the projectile. This subject gave me a lot of headache before I completed. Now from the end of the trace we need another line trace. line trace my channel, because we need this line trace to take the shape of the terrain, because if you have a if you are shooting at a location that is above your level, you need to get the position accurately. Now we needed to start from the trace end and shoot downward, plus, I know it's confusing, but this is the only logical way. Of course, someone will come with a better way, but to that time, maybe I'll change my way of making the projectile. Make this 10,000. Also to break the hit result, we need the impact point or location. Let's call it projectile end point. Let me increase this to be safe, because sometimes if you have some large terrain, you'll have some problems with it. Now what we need is a node called suggest projectile velocity. Also, let me come back here. We need to promote this to a variable and call it projectile start point. This node will give us the initial velocity of the projectile based on the end location that it will land in. So it will change the velocity. Launch speed, as we said before, it was 10,000. The start location is the socket that the socket location the projectile originates from. Or also you can put the actor location, but this will be more accurate. And the end location is the location that we found from the line trace. Overwriting gravity, do not need it. Set it to 0, only if you need to change the gravity value. Do not trace. This trace, will give you a warning if the path is interrupted and there is some objects in the way of the path of the projectile. Collision radius, these values, collision radius is related to the trace option. If you use trace, change the collision radius. Now what we need also, this velocity, we need it. What we need here, sorry, we need to make a variable in our projectile MLRS rocket. Let's call it velocity or initial velocity, new initial velocity. make it vector, and need to make it instance editable and expose on spawn. Sorry, instance editable. Here in the construction script, get the projectile, set velocity, and now we need to change the initial velocity in local space to make it false, because if you leave it true, the projectile will go in the wrong way, will not follow uh, the location that you desired. We need to put this in the construction script because you need the this script working before the spawning of the projectile. If you put it in the tick or beginner play, it will not work because it will be too late. Now let's go back to our now get this toss velocity and plug it to the initial velocity. Now also we need to use the predict projectile path by object type. Start position, same start position, this one, and the launch velocity is the same toss velocity that we got from the previous node. Projectile radius, we set it to 16. Object type, is the type of the projectile. We said it was world static, but I will change it to projectile. This projectile object type I made before, so I want the projectile to ignore the other projectiles. We do not want it to collision with each other. To make a new object type, you need to go to the project setting, go object, new object channel, make a new one and set the default response for it. For me, I made the projectile to block everything, and then only in the projectile I made it to ignore the other projectiles, because if the projectile hits itself, it will explode in the air. Now let's go back to the set it to projectile. Here duration. Now let's put it on tick. Select projectile trajectory. Now we need to first let's check. What I will make is the way to see where the projectile land. It's like a bird eye view. Something wrong. Let's see. the pitch we clamped. Let me take the socket rotations better. I found the problem. Let me just rework this. Let me delete them and rework them. Delete. Delete this one. And delete this. Because we had problems with the code. Now, we will start by getting the location of the socket. We need the socket. Take this. Get sockets location. Socket location will be the start point. This is the start point. Now, we need also the socket rotation. Sockets. The same. Break. We need the pitch. Clamp. Between 1 and 45. We do not want it to go to 0. And multiply it by a value that we this will set the range. Let me 2500. Now we also need the forward vector. Forward vector multiplied by this value and then add it to the location of the socket. Socket location, start point. This will give us the predicted place that the projectile will land in. Also, we need the plus 5000 units. This will provide us to the accurate location of the projectile arc. Here we need the end, the trace end. The start will be the trace end and the end will be the trace end minus 15,000. Or just a value that is more than this one, maybe minus 6,000. I want to sometimes if the other place is below you, you need more a number less than 5,000 by in the minus, as I said. If the other location is below your level, you need more. You need a bigger number here in the minus. Now we leave the others as the same. Also, at first we plugged the start point in the post places. Now you need to make sure that you plug the end location with the end location that we made. Now everything the same, leave it. Now let's check. Now as you see, this is the predicted projectile arc. When I go far, it changes to the 0 because the collision of the assets there is not set. Maybe let's change it to camera. It's not the trace, it is the, let's increase this by 25,000 and let's make this one minus 50,000, because as I said, the terrain sometimes give us some problems because the first trace that we made gets below the mountain, so it will give us 0. Now we don't have the problem that we had before. Now just I will make like a bird eye camera. Where is our MLRS? Let's create a widget, user widget, targeting camera, make canvas panel, so add image, image, make it 250 by 250. Leave it here. Now let's add here, add scene capture 2D, and here set the location, set world location, set it to the trace end, releasing capture, change it to 90 degrees, change this to 40 to make it zoom, and the capture, let's make a new render target. Where is my game? Helicopter, the MLRS. targeting camera. Yes, we want to rename it. Targeting camera underscore render. Now let's go to the, let's make material, open the material, change it to user interface, apply. Let's make a material instance. I'll go back to here, targeting, do you call it, targeting camera render, material instance, this one. We forgot to add it in the beginning play. Create widget. This one. Add to viewport. Now that we when we begin to play, the widget that we made, the targeting camera widget, will be active. Now we have a bird eye view, but let me first scene capture. We need it to zoom more, field of view to decrease it, and also let me get rid of the debug type. Also let me show you something you can benefit from. Let's add a spline. Let's get rid of this debug. Spline set points world coordinates. Now you can use this outpath to set to the spline, and here I'm using the spline as a example. You can use spline mesh to give you a visual representation of the arc of the projectile arc. Now let me show you. Now the camera is following the location. Now if we shoot here, now let's go far. Let's shoot more. Now need to show splines. Now you see the spline is following the arc. You can add a spline mesh or spawn some material along this spline to make you see the where the projectile is landing. I think now we've finished the video. Let me just comment. Predict the projectile arc. I think we finished. The video is becoming too long. Thank you for watching my videos. Maybe I'll see you next time in another project. Thank you.